Hello there, in this video we'll try to identify the nature of the turning points. What we mean nature of the turning points is to state whether a turning point is at maximum or at minimum position. We know that if we can sketch the graph, then we can visualize whether that point is at maximum or at minimum. But as we know, sketching graphs can be sometimes very time consuming. So the question is if there is a better method of finding the nature of the turning points, and that would be the second differentiation. The second differentiation is given with these symbols and just means differentiate the original graph twice. The procedure is that after you find the coordinates of the turning point, which are that point there, the gradient is equal to 0, then you substitute that values of x into the second differentiation, and if your answer comes out to be negative, then it's maximum, and if the second derivative at the point of the turning point it's positive, then it's minimum. So let's see one example. The question here states to find the coordinates of the turning points, so we know there would be more than one, and as we can see, this is a cubic graph, so we know that there are going to be two turning points. The first one will be maximum and the second one to be minimum, and then determine the nature of each one. So by given the graph, if we differentiate this, we find the gradient of the curve at any point. But since the question says for the turning points, we know that the gradient of that specific moment is equal to 0. So we set 3x squared minus x equal to 0. We factorize and we solve to get that the x coordinates are 0 and 2. If we want to find the coordinates, that means to find both the x and the y value. Given the x value, we can substitute it into the original equation and get the y value. Therefore, at x equal to 0, we substitute into the y and we get equals to 1. Therefore, the coordinate is 0, 1. And when x is equal to 2, again we substitute into the original equation to get the y value. And we get y to be minus 3. Therefore, the coordinates of this point would be 2 minus 3. Now, we need to identify the nature of the turning point. One way is by just looking at turning points, because we are supposed to know how this graph looks like. You can tell that 0, 1 will be maximum and 2 minus 3 will be minimum. But let's verify this with the second derivative. If you differentiate this graph once more, we get that the second derivative is 6x minus 6. Now the procedure is that we will substitute the x values of the turning points into the second derivative, and if the answer comes out to be negative, then it will be maximum, and if the answer comes out to be positive, it will be minimum. So at x equal to 0, the second derivative gives us negative as expected, and thus will be maximum. And at x equal to 2, in the second derivative we substitute it, we get a positive answer, therefore the answer is minimum.